Hello guys, welcome to this channel. My name is Sharad. Let's discuss a question based on projection of lines. Question is, a line AB 40 mm long is parallel to HP and perpendicular to VP. Point A is nearer to VP and is 30 mm above HP and 20 mm in front of VP. Draw its projections, also marks its traces. So here it's a question about projection of lines, and you have to draw its projection and also marks its traces. So first you have to understand what is a line. What is a line? Line got a both endpoints. So here the endpoints named as A and B. So it's got an endpoint A and B. Its length is, what is the length? Length of the line is 40 mm. It's in millimeter, 40 mm. So in engineering graphics or engineering drawing, the space is divided into 4 quadrants. You already know that the space is divided into 4 quadrants, and you have to understand what is HP and VP. It's saying the line is parallel to HP and perpendicular to VP. So it describes its position. So you have to first understand what is HP and VP. In engineering graphics, suppose this is a vertical plane. Vertical plane means VP. VP means vertical plane. And this is another plane. It's a horizontal plane. It's a horizontal plane. Horizontal plane means HP. So VP means vertical plane. Vertical plane. And HP means horizontal plane. Horizontal plane. VP vertical plane and HP horizontal plane. So HP and VP are mutually perpendicular. This angle is 90, and together they divided the space into 4 quadrants. First, second, third and fourth. So together HP and VP divided the space into 4 quadrants. First, second, third and fourth. So all the objects in the first quadrant are above HP and in front of VP. It may be in the HP, it may be in the VP. So generally we can say above HP, it's above HP and in front of VP. Here in second quadrant, it is behind VP. All the points in second quadrants are behind VP and above HP. This also HP, this also VP. In third quadrant, all the points, all the objects are behind VP and below HP. What about in the fourth quadrant? In fourth quadrant, all the points are in front of VP and below HP. In front of VP, it's in front of VP and below HP. So the line is parallel to HP and perpendicular to VP. So it just saying the line is parallel to HP and perpendicular to VP. So in which quadrant the line is lying? We cannot say we cannot say it's in the first quadrant, it's the second, third, because the data is incomplete. It's simply saying it's parallel to HP and perpendicular to VP. It's parallel to HP. Suppose this line is parallel to HP and perpendicular to VP. Yes, this is perpendicular to VP. It's parallel to HP. Here, this is AB. It's in the fourth quadrant. It's also parallel to HP and perpendicular to VP. Here, AB. Or here, AB. In this four position, it's all parallel to HP and perpendicular to VP. We cannot fix in which quadrant the line is lying. So we have to check the next line. What is the next line? Next sentence. The point A is near to VP and is 30 mm above HP and 20 mm in front of VP. What it says? So it says the point A is nearer to VP. Again, consider. So I am redrawing this quadrant here. This is VP and HP is perpendicular to VP. So it's saying the point A is nearer to VP. Suppose we are in the first quadrant. Suppose we are in the second quadrant, fourth quadrant. We got point A and B. This is VP and this is HP. It says point A is near to VP. That means the point A is here, not here. Means point A is nearer to VP, not away from the VP. Point B is away from the VP. Point A is near to VP. So we got first position. That means point A is near to VP. And this line is parallel to HP and perpendicular to VP. And in the next sentence, what is saying? And is 30 mm above HP and 20 mm in front of VP. It says the point A is 30 mm above HP. Here the point A is not above HP, it's below HP. That means the position of line is wrong. The position of line is in the first quadrant. Not first quadrant, maybe in first, maybe in second. So it's saying the point A is near to VP and is 30 mm above HP. The point is either here 30 mm above HP, either in the first quadrant, either in the second quadrant. Point A is 30 mm above HP and 20 mm in front of VP. That means, and it's 20 mm in front of, not behind. If it's behind, it's in the second quadrant. It says 20 mm in front of VP. That means it's our position. The point A is 30 mm above HP. From here to here, the distance is 30 mm. And it's also 20 mm in front of VP. It's 20 mm in front of VP. This is VP. The distance of A from the VP is 20 mm in front of VP and is 30 mm above HP. Suppose the point A is 20 mm behind VP. That means the point is in second quadrant. Here the point is in the first quadrant. So we got our line. So our position of the line, I am redrawing first quadrant only. This is the first quadrant. Is it clear? VP means vertical plane. This is horizontal plane, and line is parallel to HP. This is our line AB is parallel to HP, and suppose this is perpendicular to VP. And what are the distance? VP, that VP. So point A, the point A is 30 mm above HP. Point A is 30 mm. This is 30 and 20 mm in front of VP. So after reading two sentence, we got the exact position of the line. So where it's lying on the first quadrant, and this is what is the position. Is parallel to HP and perpendicular to VP. So point A is nearer to VP. A is here, not here. That means suppose point B is near to VP, means B is here. Okay. In this question it says point A is nearer to VP. This is the position of A, and it is 30 mm above HP and in front of VP. Above HP in front of VP. That means in first quadrant. So this is the three-dimensional picture of our question. Next we have to draw the projections. So suppose we are looking from this side. Here this is our point. From this side we are looking. This front view must be in the VP. The projection will be in the VP. So it is parallel, it is perpendicular to VP. That means you get a projection of this line. It's a point, right? When you are looking from this side, we only see a point, right? Because it is perpendicular to VP. This is the front view. Front view will be in the VP. Suppose you are looking from the top, and you will get a projection here. Suppose this is your projection. You will get a line. The image or the shadow will be a line because you are looking from the top, and the line is parallel to HP. What will be the length of this line? It will be the exact length of the line because it is parallel to HP, that is 40 mm. If it is inclined, suppose this line is inclined like this, you will get a projection. It's a line, obviously it's a line, but the length of the line is not equal to 40 mm. It will be in a reduced shape. Here the line is parallel to HP, so the length is not reduced length, it will be the true length. So you have to understand what is true length, what is reduced length. Okay, reduced length. True length, you will get true length only when the line or the object, whatever the object, is parallel to the projection plane. Here the object is line is parallel to HP, then you will get the projection, the length of the projection is true length. If it is inclined to the projection plane, the length will be reduced length, not the true length. So here you will get a line of 40 mm in the top view. This is the top view will be in horizontal plane. It's because it's in the first quadrant. And front view will be in the vertical plane. You are getting a front view as a point because this is perpendicular, the line is perpendicular to VP. Look, if you are looking through this side, you only see a point, that is the point B. See, so you will only show the point B, that is B dash, in the front view B dash. Behind the B there will be a point A dash. So we will the representation is like front view will be represented as dash and top view will be small letter, like here this is the point A and this is the point B. Okay, so this is the 3D of our projection. So you have to draw the 2D. How to get the 2D? So you have to rotate this plane. Which plane? Horizontal plane. Making the vertical plane constant, you have to rotate. So what will happen? This HP will come down and it will be like, see, this is your VP. After rotating, HP will come down. This is HP. So there will be a point here and there will be a line. What is the length of the line? This is 40 mm, right? And this will be your XY line. This is a 3D image. You have to redraw into 2D. So this will be your XY line. So my question is, at what length? So how much distance this point from this XY line? That is, this is the point B dash A dash. So what about this distance? This distance means this distance. That distance means this is. That means the point, how much distance is the point A is above HP, that is 30. This will be 30. And what about this distance? Here to here. This is A, this is B. What about here to here? The point A is 20 mm in front of VP. That means this distance from here to here, it is 20 mm. That means this is 20. Right? You got it? So how to draw this projection? Its projection. How to draw its projection? You have to draw XY line. This is your XY line. This is your XY line. You have to first mark this point. This point is 30 mm. The scale, you have to mark this 30 mm. This is 30 mm. And this point is 30 mm. You have to first find out this point. This is 30 mm. 30 mm above HP. So this is your point B dash, in the bracket this A dash. And below, what is this distance? This is 20 mm. Mark the 20 mm. This point will be A, and mark a 40 mm. This is B. This is 20 and this is 40. All dimensions are in mm. In millimeter. All dimensions are in millimeter. So the first part, its first part is over. What is the first part? Draw its projections. So I draw its projection. And what is the second part? Also marks its traces. So what is a trace? What is a trace? So trace is a point. Suppose this is the line. When you extend the line, it will definitely meet any of the projection plane. Here this line is parallel to HP and perpendicular to VP, right? So when you extend this line from this side, it will not meet any projection plane. Suppose if you extend this line this side, this will meet VP at this point. That point because that is called vertical trace. XY line, this is our XY line, XY line. So here, look at here. So this is our XY line. This is our XY line. I am drawing. This is XY line here. Okay, this is our XY line. And next, after XY line, we have to spot this point B dash, A dash, and then the line B. So what is saying, a line AB 40 mm long is parallel to HP and perpendicular to VP. So first you have to point A. Point A is nearer to VP and is 30 mm above HP. After reading the question, this picture will be in your mind. In first place, in your mind, this picture will be in your mind in the first place. Okay, you got it? After reading the question, you have to make a 3D image of this question. So the point A is nearer to VP and is 30 mm above HP. 30 mm above HP. Above HP means it's in first quadrant. Above HP and 20 mm in front of VP, first quadrant. So you have to first draw a line. Roughly you have to draw a line. And then this is 30 mm above HP. 30. This is 30 mm above HP. And 20 mm in front of VP. In front of VP. 20 mm in front of VP. This is 20. Okay, this is this point, this is B dash, in the bracket A dash, and this is A dash. And what is the length of the line? The length of the line, what is the length of the line? Length of the line is 40 mm, right? This is 40 mm. This is B dash, not dash. There is no dash because it's in the front view. Sorry, there will be no dash, just A and B. On dash is only in dash means B prime or A prime, a B dash or A dash. It's only in the front view. In the top view, we usually represented by small letters without this prime or dash. So this is our line, 40 mm. This is our line. This is our point. So you will be see a dot or point in the front view. This is vertical plane and this is horizontal plane. Next is you have to dimension this projection. So how to draw dimensions? It's very simple. It will be thin lines, not the sharp lines or the darker lines. The line and point will be in the darker or bold lines. So other lines will be thin or not light lines. So this is how much distance above from the XY line? It is 30 mm. So just write 30. And how much distance below XY line, or how much? This is 20. Just mention 20, not mm, just 20. And here, what is the length of the line? The length of the line is 40. Okay, the length of the line is 40. So you have to write here all dimensions are in mm. That means millimeter. All dimensions are in millimeter. Okay. In the second part of this question, it's also asked to draw its traces. Like here, also mark its traces. So you have to understand what is trace. Suppose this is in the first quadrant. This is a line AB which is inclined to both plane, which is inclined to HP and VP. This is in first quadrant and it's inclined to both planes. I am going to extend this line. It will meet one point at HP, and after again if I extend this line, this is our VP, it's gonna meet another point on the VP, right? 2 points. in this side if you extend it never be gonna meet any projection planes. So what is projection? Projection means if you extend a line and suppose the line meet horizontal plane at a point, that point is called horizontal trace. If the line meets a point in vertical plane, that point is called vertical trace. So this is the definition of horizontal trace and vertical trace. So in our question, this is our line. If I am going to extend this line this side, it never be meet any plane, because it never be meet any horizontal plane, because the line is parallel to HP. Okay, it never meet horizontal plane. Suppose what about the vertical trace? Suppose I am going to extend this plane along this direction, it will meet a point, that is the same point, this projection point, that is the vertical trace. Okay, that means the point itself is the vertical trace. So you got the vertical trace. So this point is also vertical trace. Just mention this is the vertical trace. So here the vertical trace is this point itself is the vertical trace. So this is the vertical trace. Just mention this is the vertical trace. Okay, thank you.